Okay. Talked about alkanes. Now we're going to go to alkenes. Alkenes. I don't know why I want to enunciate it like this. Alkenes. So these are unsaturated hydrocarbon molecules that contain one or more double bonds. So think less hydrogens on that carbon because you have some double bonds. Okay. I feel like I just went in the wrong direction. Give me a second. All right, here we are. So here are some examples. So you may notice, right, just like with two carbons, it's ethane, three propane, four butane. And now all we've done is switch the name to ene instead of n, right? So ethene, ethene, propene, one butene. So naming, right, derived from the name of the alkane with the same number of carbons, as I just said, and you're just replacing the A and E suffix with en. So the location of the double bond is identified by naming the smaller of the numbers of the two carbons. So basically, if you have, carbons 2 and 3 with a double bond, you're going to name it as 2 with the number 2 because that's the lower number. So here are some examples, right? Let's go right here to this example. We've got 4 carbons. There's a double bond between carbons 2 and 3. So instead of naming this 3-butene, we name it 2-butene because it's the smaller of the numbers. We call this 1-butene because we have, right, carbons 1 and 2 connected via a double bond. So we can name it 1-butene. Propene, ethene. And these names you see in parentheses are just common names that are used. So we can have isomers of alkenes as well, structural isomers that have different connectivity. So we see here, right, we have 4 carbons in both of these, but instead of a ethyl group coming off of this carbon here, we could have a methyl coming off of each carbon. So these are structural isomers. Another kind of isomers we can have is geometric isomers, where the connectivity is the same, but there's just a different orientations of groups around the double bond. So here's an example here, right? These connection is the same, as in we have 2 carbons connected by a double bond. Each carbon has 1 methyl and 1 hydrogen, or 1 methyl substituent. We don't really call hydrogen a substituent. Or do we? Did I just make that rule up? Fact check me on that. I don't think we do. But more importantly here, both carbons have a methyl and a hydrogen group coming off of them. So in that way, I think yes, hydrogen is a functional group. But just notice the orientation of the methyls and the hydrogens are different. So when these methyl groups are on the same side, right, this is what we call the cis conformer. And when it's on the opposite side, we call that trans isomer. So just taking together the two types of isomers that we looked at, right? We looked at how 1-butene is different from 2-butene, structural isomers. But within 2-butene, we can have these geometric isomers in both the cis and trans conformation. All right. So we went alkanes, alkenes, now we're on alkynes. These are hydrocarbons with one or more triple bonds, right? Also unsaturated, even less hydrogens on that carbon. We have one sigma bond and two pi bonds, so they form a 180-degree angle, which makes them linear in shape. Naming is like alkenes, but we just replace the E-N-E with Y-N-E. So let's look at an alkene. Here's an example. We have so instead of ethene or ethane, it's ethine. The common name is acetylene. We also could name this one butane. I know, y'all, it's a lot of names. A lot of names. I didn't make these names. I would have picked one name and stuck to it. But nonetheless, we have many names. So we have these two carbons connected by a double bond, example of an alkyne. All right. See you in the next.